Yes, yeah. Before I go, right, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, sir. Visible. Yes.
The last class,
Yes, it is clear to us.
loading data and filtering, right? Filter those employees, right, whose salary is about 20,000. Is the task. Now, one more task. Observe this example too, right? So let us open this Pyspark, Pyspark, Pyspark. Getting records of a particular getting records of a particular department 11, right? Getting records of a particular department 11. R1 equal to SE dot text file, SE dot text file, TFF is HDFS colon / localhost, HDFS colon localhost. What is the port number at? Port number is what? 9,000. So I was saying that ST in core icon side dot SC dot text file, HDFS localhost 9,000. Right. Right. Slash scoop D. Okay. HDFS localhost 9,000. Like what is the Pyspark 6:30 p.m. right? Yesterday we have created a folder Pyspark 6:30 p.m. In that, what is that EMP file? What is the name of the TMP file? One second. Exit controller ls you say emp1.txt file, right? Yes. So we have copied one emp1.txt file. As I said, how to increase the number of partitions while loading itself, right? Try to answer. How to increase the number of partitions by loading a HDF.
Comma 2.
Yes, comma, then we
While
can
loading
provide
only,
the number.
yeah, while loading only, we can give comma and give the number of partitions you want. Here we can control the number of, we can control the parallelism in Spark. The case of Hadoop, we cannot control. It all depends upon your blocks. How many blocks? Those many. Here we can control how many, what is the value you give into 3 or into 4 into 5. Right. whether whether this file got loaded based on which columns partitions will be created means not based on columns. If there are if you got some two partitions, if you got 10 records, 5 records you will see in the first, 5 records you will see in the second. Not not like Hive partitioning is different and this is different, right? If you got 10 records, right, in the EMP file, first, okay, if you are creating two partitions, in the first partitions you will see 5 records, in the second partition you will see 5. R1 dot collect, if you say whether they are loaded or not, you can check whether they are got loaded or not, you can say, right? Check it. Yeah, list of all the files you got 1, 2, 3, 4, 5 records you got 1, 2, 3, 4, 5 records, right? Now, what is my query? I want only department number 11. You got some records, you got think that you got some 1,000 records, employee records. I want only department number 11 from it. Yesterday we have discussed it, how to filter only those whose salary is about 20,000. In the same way here, what is the next step here?
We have to split.
Yeah, we need to split that each record, so that if you want a particular column, if you want to access, split it. If you split this record, if you split this string, you will get list of 5 words. List of 5 words. Which word you want from that, you can access. I want department number. Based on index, you can access. So try to say me that R2 is going to get created. How R2 is going to get created? Try to respond.
Map.
R1 dot map.
Map.
R1 dot map. R1 output you map with
Lambda.
lambda x. X means each record. X means each record. Each record. First it takes first record. X dot splitting based on splitting based on comma, because between the now you see the result. R2 dot collect. Now you will get list within lists. For every record you got one list. Every record one list. For every record one list. Okay, from this next what I want, filtering based on condition. Filtering based on condition. Filtering based on condition. Try to say how to filter based on condition. On R2 dot filter, R2 dot filter. On R2, I want to filter. What is the filtering condition? Lambda x. X means each one. Each one is what? Each element is what? What is each element? List.
In the index.
Each element is what?
List.
Okay. R2 dot filter, right? Okay, on R2 dot filter lambda x means each list. First x takes the first list. How to filter the condition? Try to say.
X of 4
X of 4, yes, x of 4. If it is
equal to
equal to 11, only that. 11 is
Sir, your voice not clear.
Your voice is breaking actually.
hello.
Yes, sir.
Is my voice breaking to all? Once confirm everyone.
And now it is fine.
yes,
Yes,
it
it
was
was
breaking for
breaking.
a minute.
Now it is fine.
1 second, 1 second. I'll make it clear. Okay. R2 dot filter lambda x of 4 if it is equal to 11. If x of 4 is equal to 11, only those records. Yes. Close it, right. Store it in R3.
So filter will be also applying for the each and every record like map.
Yeah, filter lambda is for each element, right? So here map is for what? The output of R1 output map this transformation.
Yeah, because map is
Filter,
going to apply in each and every record, right?
what is
Because
the
I need
difference?
a
What is the difference between map function and filtered function? In map, if you're applying map, right? If you got 10 records, in the output also you'll see 10 records in map.
correct. Yeah.
Filter means you won't see all the 10 records. You will see only the specific 3 records or 4 records.
But
Whatever
internally it will be validate the each and every record, right?
internally, yes, it's valid each and every record, but map returns all the map means each element of transformation for each and every element that is going to be applied transformation. Filter also it checks with each and every element, but it won't perform any transformations to each element. It will just filters it. Filter
Okay,
doesn't
okay.
apply any transformation to that particular record. It just filters the record. Map means it is applying some transformation to every record. Now see this R3 equal to rewrite. R3 dot collect, R3 dot collect. You can see that R3 dot collect only those. Yes. Only those, right? Which have got department number 11, 11. Okay, once. Okay,
And
next.
hello, sir. If you want to add the another condition, then like department number 11.
End. A and you can give. End condition you can give, right? I want the end.
Why two times filter is applied here, Vinay?
Hmm?
Why two times filter is applied?
Where to,
Okay,
okay.
two times you have applied the filter.
This one I didn't store anywhere in R3. Next one I stored in R3. That's not
That
required.
is not required. Okay.
So this output I stored in R3 and R3 dot collect. Because R2 dot filter, if you're performing a transformation, you will get an RTD, a new RTD created. Store in R3.
Means sir, and R2 filter like that.
R2 dot filter.
Means if I want to apply another condition, then and R2 dot filter likewise we have to return. We need to return that.
For example, I want is it valid? Lambda x of 4 equal to 11 and x of 0, 1, 2. Greater than 20,000. One thing, what is there?
You have 2000 have written
2000 I have written there. Let's make it 20,000.
It should be one record.
But here, 1 second. Okay. R4 dot collect. Here, you need to observe carefully. 11 you have given as string, 20,000 you have given as integer. But in our all our strings here,
Typecast X up.
So do one thing. Extract this name, department number, and salary. How to extract only the department? R4 equal to R2 dot map, you say. R2 dot not filter, R2 dot map, you say. Lambda x from each record. What you want? Name means x of 1. Starts with x of 0, x of. Next, x of 2 you want salary. But convert to int of x of 2. Next, department number also, right? Int of x of 4. You got name, salary, department. Now on this R4, create R5 equal to R4 dot filter you apply now. Filter BD lambda x 0, 1, 2. X of 2 equal to department 11 and salary x of 1 greater than 20,000. Yes. alpha dot collected. Only one, right? Yes. In this way. Multiple conditions, but applying multiple conditions. Applying multiple conditions, right? Apply if I want to apply multiple. Yes. Next. Word counter. To count the number of occurrences. To count the number of occurrences of each word in a file. To count the number of occurrences of each word in a file. For example, each word in a file means, okay, Control L. There is a word comment. You know how to create a file. What comment? Spark is simple, Spark is distributed, Spark is for processing, Spark is in memory computing system. I want how many times each word is repeated. How many times each word is repeated. The count of Spark, the count of is, count of the various other things, right? HDFS, DFS, hyphen, put comment is the file into slash Pyspark 6:30 p.m. right? 6:30 p.m. This is HDFS command. Put comment into Pyspark 6:30 p.m. right? Now, check this RTD1. R1 equal to, check this R1 equal to sc.text file, localhost Pyspark 6:30 p.m. The name of the file is comment. Comment, right? The name of the file is comment. Next, R1 dot collect, you say.
Here only one partition should be created, right? For this command file.
Only one partition is created. Spark is simple, so you will get list of strings. List of strings you get, right? Yes. Now, if you split, you will get words. I want words, each word repeated from n times, right? Splitting.
So how it's got splitted by the collect is based on the inter line by
What is-
line.
Yes, line by line. If there are
Okay.
5 lines, 5 elements you say. Splitting, splitting. What is that? Splitting each record. We get list of words. Splitting each, we get list of words. RTD2, RTD words, RTD words equal to RTD underscore words, right? R1 dot map lambda x dot split based on space. Why based on space here? Previous Spark is simple. Between each word space is there, the splitting based on space this time. So how you will get words, right? If I split each, x is first line. If you split it based on space, you will get list of 3 words. So similarly, second one it takes split list of 3 words, list of 3 words. You will get list of 3 words for all this. ODD underscore words dot collect. List of words you got, right? For every line you got word, list of words, list of words, list of words, right? Spark is simple. For the second line, Spark is distributed. Spark is for processing. Spark is in-memory computing.
Yeah, so if special characters are present within the text, then how it will process?
Special characters are, what is it?
Like at the rate or hash.
Whatever it is, right? You split based on space. Here, based on that, if you got a line or if you got a record, customer or employee or student or any orders data, right? What is that separator or delimiter between them? You see and split it. If you got any other than this space, comma is there or tab space is there, any other dollar is there, anything split based on that. You will get list of words. Now you got list within list, but I doesn't want like this. I want a list in which I want all words in it. Flattening the array, flattening the list. Now flattening the list. Flattening. Now flattening the list. Now flattening the list into a single list. Flattening the list into single list, right? Yes. How can I do this?
Use flat map.
Flat map, right? Yes. I'm saying words one equal to, it's an RTD. RDD underscore words. RTD underscore words dot flat map. RTD underscore words dot flat map. Lambda x gives x. RTD underscore words dot flat map lambda x of x, right? Means flat map already we discussed. Flat map flattens all the inner list into one list. Check this. Words one dot collector. We have seen about transformations, each element transformations. Or key, comma, value pair. You got list of words now. You got list of words, right? Now, so we can also perform combining about combining the above two steps. Or I'm saying or, right? I'm combining the above two steps. I want to combine the above two steps. So just by using flat map, just words one equal to R1 dot R1 dot flat map. Whatever we did till now within a single step, we can do it by using flat map. Lambda x, right? X dot split, x dot split, x dot split based on space, right? Yes. R1 dot flat lambda x dot split based on space. Words one dot collector. Words one dot collector. So the same output, right? Instead of again, first time you split it, second time you combine it, but within a single step, you can do both splitting and combining using flat map. Now I can apply reduce by key, right? How many times each word repeated, but reduce by key. To apply reduce by key. To apply reduce by key. We require key comma value pair to apply reduce by key. We have one key come, but only key is there. Value is not there. I'll give one. I'll give one as the value to each and every word. For every word, I will give the value as one. Now observe. So add one. So add one to each word. To each word as key. Key comma value and form a key comma value pair. Pair equal to words one dot maps. Pair words one is there, right? Words one dot map lambda x. What is x means each element. Each element means each word. Observe carefully here. I want to apply reduce by key. I want to add one to each word. So x means each word. X means each word. To each word, add one. X comma one word comma one you will get, right? Check this output one pair dot collect. Pair dot collect. Pair dot collect for every word. Spark one is one. Simple one. Spark one. For every word one. Now it's ready for it's ready to be reduce by key can be applied. Now I can apply reduce by key, right? The data is ready as key comma value pair where reduce by key can be applied. RES equal to now say pair dot pair is that RTD. I can apply reduce by key, reduce by key. Lambda x comma y gives x plus y. X comma y. Or yes, pair dot reduce by key. X by y gives x plus y, right? Yes. Or yes, dot collect. Spark for how many times? 4 times. Is for how many times? 4 times. Remaining all for 1 time. Okay, fine. How many words?
Can you explain the reduce by key x plus one how it's
Reduce by key x comma y gives x plus y means all the similar spark, 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 spark. It groups it. the values will be aggregated 1 plus 1 plus 1 plus 1 x plus y. How many?
How it's
How many?
identified? It's
How
how it
many?
will be
How
identified.
many? So how many? Okay, 1 second. 1 second. So while discussing transformations, right? The behavior of reduced by key we have discussed. So here 11 India 1, England 1, Japan 1 medals. India got 1, England got Japan, India, Japan, India, England. So it will all the India it will groups and aggregates its values. All England it groups and aggregates its values and sums its value. All Japan, how many keys are there? Each key it will group and aggregate this. Means India 1 plus 1 plus 1 is totally 4. 1, 2, 3, and one more you can see here at the last. So it will group that India and aggregates its value of 4 you will get. Here also in the one more example, department 11, 12, 13 is there. All department 11 it groups and aggregate their values 10,000 plus 50,000, that is 60,000 you will get.
Okay. Yeah.
X comma y means x means this, y means this. Salaries only. X is first salary, y is second salary. Each time it will okay. It will, for example, salaries are like this. For department 11, it will groups all that 10,000 is one salary available, 20,000 is one salary. Assume multiple salaries are there. 40,000. Department 11, 4 salaries are there. Okay, all the department 11, these are the salaries. This it will take as X. This it will take as Y. And X plus Y, what is that you will get? X plus Y? 30,000, right? This 30,000 will be taken as X now. And the next 30,000 will be taken as Y now. Next. Now what is that output you get? 60,000. X plus Y. 60,000. And 60,000 will be taken as X. And next 40,000 will be taken as Y. 40,000. Now X plus Y. Finally, what is that? 1 lakh. In this way, every time it takes X, Y and performs X plus Y. First, it takes these two X, Y, X plus Y. The output will be taken as X. Next one will be taken as Y. Again, in this way, performs. Similarly, here also, right? In our example also, right? In our example also, right? Spark 1, spark 1, spark 1. So it will say spark 1 comma 1 comma 1 comma 1. It will take the first X as X and this is Y. 2 you will get. 2 will be taken as X, the next one as Y. 2 plus 1, 3. 3 plus 1, 4. That is what how it aggregates. Okay, fine. 1 second. How to bring data from HDFS? Creating an RTD. Later splitting it. You will get list of words. The words again you are flattening. You are getting as one list. And on that you apply key comma value to apply reduce by key. Yes. Okay, fine. This example, understood, right? So how to split and how to get and how to extract the data, how we are extracting the data, right? Yes.
So now if I want to get only the spark from that list, how do we get it?
You want only spark from that,
Yeah, yes,
and doesn't want all, you want only spark.
yes.
Filtering operation, where x of 0 equal to if x of 0 equal to spark. Here in the previous first example, yesterday's example, I want only, you got tuples like this. You got names and salaries, I want only those whose salaries are about 20,000. X of 1 about 20,000. But here if you want only spark, x of 0 if it is double equal to spark, that filter operation you can. Okay, let us do that. Now, what is that final RTD pair, right? From the pair only like only that spark if you want.
Final is RES, I believe.
RES to equal to, from RES is the last one. RES
Yes.
is not RTD, RES dot
Filters.
filter, RES dot filter, right? Filter. How to lambda
Lambda X.
X means each element. Each element is one tuple. From the tuple,
X0.
x of 0, if it is equal to x of 0, if it is equal to spark.
Now one you have added here is by default int, right? Not in a string.
No, yes, it's an integer. If it is string, it will be in single quote. Quotes it will be. res2 dot collect. Only spark how many times? 4 times. I want the count of, I want to count of only spark word.
Then the final code no need to be every times no, do the collect method, right? At the end only we have to use it.
Only
Right?
one minute, but I want to show each one output. I'm saying every time collect, but only at
Yeah,
last if it's
yeah.
every time
Okay.
I'm saying to see the every line output, I'm saying collect. But if you say at the last one collect is enough. Next is
Okay.
groupings and aggregations. multi-grouping and single aggregation. Single grouping and multiple aggregation. Single grouping and multi-grouping, case 4, right? Task. Already single grouping, single aggregation we have discussed. Say one more example on this. And department number wise, I want sum of department number wise, I want sum of SAP from EMP group by department number, right? Department number wise sum of SAP from EMP group by department number I want. Single grouping, group by single field, aggregation also on single field. Output I want like this. Output department 11 total cell, 12 total cell, department 13 total cell. Okay, I want output like this. Now try to say, right? Try to perform this just before we have seen department number wise sum of cell. First, loading the data. Loading the data, right? Yes. R1 equal to, try to say R1 equal to, everyone, sc dot text file, xc dot text file, hdfs colon / localhost Pyspark 6:30 p.m. /emp1.txt right? Yes. Next, we say r1 dot collect. R1 dot collect, if you say, right? Yes. You will get this. Step 2. What is step 2? I want a department number and salary to be extended. I need to split each record, right? Splitting each record. Splitting each record. 1 second. Splitting each record, we get list for every record. We get list for every record, right? List of R2 equal to R1 dot map
Map.
lambda x gives x dot split. Splitting based on what? Comma again. Splitting based on comma. R2 dot select. Yes, you get list of lists. Step 3. Extract the required fields. Extract the required fields. Extract the required fields, right? Yes. R3 equal to R2 dot map. R3 equal to R2 dot map. Now extract the required fields means department number and salary only, right? Department number and salary. Lambda x.
X of 2 and 4.
X of 4 department number, comma, int of x of 2. X of 2 is what? Salary. I want to convert to integer, right? Yes. One more bracket required? Yes, right? One more bracket required. R3 dot collect. R3 dot collect. R3 dot reduce by key. R3 dot reduce by key. X comma y gives x plus y. R3 dot reduce by key lambda x comma y gives x plus 1.
So here we will not use group IQ key because of that shuffling performance issues, right?
Yeah, only one aggregation required, some aggregation, right?
Okay.
Department 11 total are reduced by key.
Got it.
RS dot collect. You will get department 11 total sum, department, all this, right? Yes, this is single grouping, single aggregation. Department 11, 40,000. Department 12, 60,000. Department 13, 50,000, right? Yes.
And
But,
that group by
Vijay,
key,
what do you mean by single grouping and a single aggregation actually? Grouping, how do you say that this is single grouping? I did not understand actually.
Any query was asked? Hello?
Yeah,
sir,
Vijay, did you hear me?
Yeah.
Ask.
Go ahead. Can you please repeat your
Yeah.
query?
I was asking like, how do you say that this is single grouping and single aggregation actually? I don't understand actually here.
See, aggregation, okay, single grouping, single aggregation means I am performing some aggregation. Single grouping
Uh,
means grouping from single field department number only, right? Single grouping department number only you are grouping. And only one aggregation. Multiple aggregation means sum will be there, max will be there, min will be there, right? All multiple.
Aggregation means like adding of all the value, you mean? That's the meaning of.
Okay, so here, single grouping means here I have taken only one x of 4, only department number I have taken. And here reduce by key is applied only on this salary field. So reduce by key performs only some aggregation. It cannot perform any other aggregation. That is single aggregation. Reduce by key performs single aggregation. And a single grouping, here only one group, one key, one value. Okay. So in group by key, you can perform multiple aggregations. Here, 40,000 you will get. Beside that 40,000, average salary you will get, min salary you will get, count you will get, max and min, everything you will get. Here only some aggregation only you are getting, right? For department level, you're not getting average or max or min or count. Only one value, 5 values. That is what multiple aggregated values you will get for multiple aggregations. Multi grouping means department wise or city wise, department number wise, that is the total salary. Okay. So in the next cases, you'll understand. What is
Sir, yes. So, sir, so this is a very small data. So, if they are dealing with a very huge data, so in that case, do we need to sort before we group, performance aggregation,
no.
or is it required?
Here we have got 5 records. If you have got 5 lakh records, same code. We
Okay.
no need to sort the data. No need to sort the data here. What is the necessary value pairs you will get? But if you got 5 lakh records, 5 lakh key value pairs you will get. And reduce by key, all the department levels, it groups and aggregates the values.
Okay. So sort does not add any benefits before the group unless it is necessary.
When you apply reduce by key, x plus y means both are values only. No, there is no key applied there. Yes. And what is x comma y gives x plus y means both are all the 1 by 1 values. One x takes the first value, y takes the second value, aggregates. Thus output again aggregates with the next one. Okay, fine. Okay, fine. So that in the multi groupings and multiple aggregations, you'll understand, right? What is the difference between single grouping and multi grouping? How these groupings are done. Okay. So as I said yesterday, right? I need to start early today. I need to leave. So I'll stop for today. I'll forward you the notes once check it, right? Fine.
Sir, one question I
I'm
have.
stopping for now. We'll continue.
Sir, if we
Yes.
process Parquet file and tag .csv file in a Spark, then what file will give
Yes.
the best
I'll show you
performance?
those, how to work with CSV files, JSON files, Parquet files, handling
Okay.
those files. Right?
Just performance wise, I wanted to ask which file will give more performance? CSV file?
Files, JSON files. We have got some file formats, different file formats. Directly. What is it? CSV.
Your
Okay.
voice is breaking, sir.
Yes. Okay, I'll discuss about
CSV
the
file. Okay.
I'll discuss all the file formats in the coming session.
Okay. Okay. Thanks.